We're filling in these like little triangles and trying to decide if the triangles were congruent to each other or not. So far what we've learned is side, 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 and we've learned side, angle, side, right? So for letter G, we noticed that we had the same segment, the reflexive property, and so we marked that in. And so then we could say, oh, it's going to be side, angle, side. So on this next one, on H, we have two markings that are the same for the side lengths, and we have two markings that are the same for the angle lengths. Now we can do the line in the middle, but if we go around, so if I look at just this triangle right here, it kind of helps to kind of zoom in. We have an angle, and then we have a side, and then we have a side. So you kind of go like around the triangle in a certain order. Does this make sense? Do you guys see why we can't call it angle and then side? Well, we don't go this way. We don't go say angle and then side that way, because we would have skipped over that side. So it's like the consecutive things. Do you guys get that? A lot of people have trouble with that concept. So it's angle, side, and then side, which is the bad word, right? So can we say that these are congruent to each other? No, it's the one that doesn't work. So this is no, it doesn't work. And then this next one, so we have side, and then an angle, and then a side. Do we have the exact same markings on the following triangle, on the other triangle? Yeah, so we can say yes by side, angle, side. So I also asked you to write the triangle congruence statement. Okay, so if you hear me say that, and I say that on your homework a lot, the triangle congruence statement, what I want you to say is triangle something is congruent to triangle something, okay? So if these are congruent, we're going to go and say that they're congruent. So if I go O, N, M, let's say, think about what it's going to be on your paper. So O, N, M is going to be the same as, what do we think? M-L-O, perfect. Does that make sense? Do you guys see the order that we went? Okay, and if I say triangle A-N-G, let's say, it's going to be the same as what?
R-W-T.
Exactly, R-W-T. That was a nice one because they're already oriented in the same position, right? They're already kind of lined up so you can see it. All right, do these make sense?
Yeah.
All right, so number 5, so it said on the coordinate grid below, graph the following 6 points. So we have N, which is -5, 1. Very tiny little grid. P, which is -1, 6. And then we have M, which is -1, 1. And F, which is 2, 6. Got a lot going on here. 2, 6. D, which is 6, 1. And E, which is 2, 1. So N, P, M. So it says use a triangle congruence postulate to show that NMP, or NPM, NPM is congruent to DFE. Okay, so when we have these set up, so we have this grid drawn in, we're going to find a lot of things on it. So what do I know about these two triangles? Anybody have any things they can tell me, like measurements they can give me, maybe angle measurements, side measurements? What can we do? What do we think? What type of triangles are they? Right triangles. Can we say that these two angles are perpendicular to each other, or these two angles are 90-degree angles? Yeah, I think we can say that, right? We could say that those two sides that form the angle were perpendicular to each other. So yeah, I'm going to say that angle M is congruent to angle E because they're both right angles. So on a proof, that reason would be all right angles are congruent. That's kind of a theorem, but it's a pretty easy theorem to just write out. All right angles are congruent. All right, do we know any other measurements? So how about the length from N to M? Can we find that? Yeah, what do you think? 5. Is that the same for the length from E to D? No, it's not? Uh-oh, I think I meant for them to be the same. 1, 2, 3. Oh, they're both 4, I think. So we have 4 and 4. All right, so we have, if I want to talk about a length, I do NM, no line over it, is equal to 4. And ED, no line over it, is equal to 4. So that means that NM is congruent to ED. Does that make sense because they have the same measurements? Do we know any other measurements? How about P and M and F and E? 1, 2, 3, 4. Is that 5? 5 and 5? Yeah, so we'll do the same thing for that. So we're going to say PM is equal to 5 and FE is equal to 5. So PM is congruent to FE. Is that enough to say that the triangles are congruent? What do we have? Side angle side. Did you guys see it? So we're going to say, so triangle NPM is congruent to triangle DFE by side angle side, or side angle side congruence if you want. Does that make sense? So we don't have to go through all 6 things being congruent. We don't have to do all 3 sets of angles, all 3 sets of sides congruent to each other. If we can do side angle side or side side side, we're good to go. There's going to be a couple more that we're going to learn too. All right, so this last one. So it says number 6, supply the missing reasons for the proof below. Okay, so this one's a little bit tricky because there's one more step at the end, and we'll talk about what that is. It's going to kind of lead into a section that's not the next section, but the following section. Okay, so it says given WZ bisects angle XZY. So when I use the word bisects, I know that means it cuts it into 2 congruent pieces, right? So that means that this angle right here is going to be congruent to this angle right here, because I knew WZ bisected angle XZY. Does that make sense? And then I know XZ is congruent to YZ. That was given to me. So my first statement was WZ bisects angle XZY, and XZ is congruent to YZ. So that reason is going to be given. Easiest point on a test, right? So why do we think we can say that angle 1 is congruent to angle 2? I drew that in. Why did I draw it in? Are you guys getting hung up on like trying to say, oh, it has to be a theorem or a postulate or whatever, right? Why did I know I could draw that in? I used what word? Bisect. So I'm going to say definition of angle bisector. Exactly. So definition of angle bisector. WZ is congruent to itself, WZ. Any ideas on this one? Yeah, reflexive property of congruence, because there's a congruent sign. Or remember, you could say same segment. I'm cool with that. All right, triangle W or XWZ is congruent to YWZ. So I said WZ was congruent to itself, so I'm going to draw 2 little tick marks in there. Right there. And what do I have when I want to talk about this triangle and this triangle? Side angle side. They're congruent by side angle side. So if you were just write SAS, that's fine. My summer geometry students called it SAS, if you want to say SAS. I'm cool with that. I don't know what you call side, 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 I guess. I don't know. All right, and then, so now that we know those 2 triangles are congruent, let's think about this. Okay, when I first taught you about congruent polygons and congruent triangles in particular, I said congruent triangles have all 3 corresponding sides congruent and all 3 corresponding angles congruent to each other, right? Now that I know those triangles are congruent, I can say that all of their corresponding pieces are the same. Does that make sense? Because they perfectly match up on each other. If I put them on patty paper and put them right on top of each other, all the angles and all the sides would match up, right? So this next thing says, well, why does XW have to be the same as YW? Because those triangles perfectly match up on top of each other. Does this make sense? So now if we know that the triangles are congruent, then every single piece of those triangles has to match up. Okay, so we have a special name for this. This is corresponding parts of congruent triangles are congruent. Can you say that 10 times fast? Corresponding parts of congruent triangles are congruent. It's a mouthful. Will you guys try it? 1, 2, 3. Corresponding parts of congruent triangles are congruent. It's a tongue twister. You know what we write? CPCTC. So CPCTC, corresponding parts of congruent triangles are congruent. There's a song to Farmer in the Dell. I will not sing it for you because I'm a terrible singer. But if you would like to look it up, you may. All right. So does this make sense? All right, so we're going to move on to the next section. Let me go ahead and stop this video, though.